Design intent is the intelligence we as designers build into our CAD models so that they'll change predictably. The issue is, in a history-based CAD system, nobody knows what the intent is other than the original designer. This could prove to be problematic if the designer is no longer available or doesn't remember how the part was put together. To illustrate the problem, we've been sent some markups to make to this old part. For our first change, we need to add some extra material to the slide in order to create additional clearance between features. We have instruction to change our slide body to an overall height of 31mm. The second change is to increase wall thickness between the cylinder slides and the cutout to 4mm, as we're seeing some problems with deformation. And finally, we need to add at least 2mm of clearance between these counterbores, as our new manufacturer is reporting a blow-through risk. First, we'll attempt to make these changes like you would with most any other CAD system, using a history-based approach. Then, we'll make exactly the same changes using synchronous technology. So first, history-based, and to help compare, let's set a timer going in the top right. So for the first edit, we click on the model to edit the sketch of the highlighted feature, assuming this is the correct feature. Luckily it is, and we're also lucky that we have a fully defined sketch with a dimension of the geometry that we need to change. We'll change this to 31mm as required, the sketch is updated as we'd expect, and then rebuild the model. We have a problem. Due to inappropriate design intent, this cut on the right has shifted, so we need to go in and fix this by editing the sketch relationships. Only a minor issue there to resolve, 34 seconds of editing, but let's do the same revision using synchronous technology. Timer restarted in the top right, and for this same change, all we need to do is place the required dimension in 3D, no sketch work in sight. Solid Edge has recognised the design intent of the geometry here. It sees that there are quite a few faces to keep in line. However, as you can see, we can intervene on the fly if we wish. Solid Edge was right the first time though, and furthermore, notice that we're able to keep the model symmetrical. No issues about fixed origins or coordinate systems, 22 hassle-free seconds. Back to history base for the next change, and before we make any edits, we need to find out how much material we currently have between the cylinder and the cutout. Measuring it finds it to be 2.5mm. We need to make this a total of 4, so we'll add 1.5mm to the radius of the cut. Again, we'll go in and edit the sketch of the feature and use Solid Edge's ability to enter equations in the dimension box to simply plus 1.5mm. Rebuild the model and... it's clear that the original design intent wasn't set up for this type of change. We now have interference with our slide positioning holes. So let's undo that change and go back to the sketch to correct the design intent. We'll speed through this to save you falling asleep. Okay, sorted, and we're at 1 minute 34 seconds. The same change using synchronous technology, and dimensioning the two radii here isn't limited to just taking a measurement. Instead, we can immediately type in the 4mm clearance value required. As for design intent recognition, not only does Solid Edge allow us to add material rather than shifting the cylinder slides up, but it also recognises that we'd want the other side of the model to change too, as it's symmetrical. Now for our final revision, and back to a history-based approach for the last time. In order to get a better idea of what we're working with, we'll create a section view through the model so that we can get a better understanding of where that blow-through risk is. Okay, here it is. So we'll be editing these two counterbores, and let's take the lower one first. We'll go into the sketch and modify the dimension that's controlling its position, subtracting 1mm. Again, we'll use the equation in dimension box method for ease. We need to do the same with the top counterbore to total our required 2mm clearance, but repeating the same steps, notice that this wasn't created in the same way as the previous. Instead it has two cuts, one concentric to the other. These sorts of frustrating situations are often run into in history-based modelling. Design intent may not be what you'd naturally expect. It's all down to the original decision and creation. Another fix required. Re-examining our part to make sure everything is how we need it. Notice that we now have an issue relating to the rear counterbore. It doesn't line up with the front counterbore we edited earlier. Again, the setup of the original design intent means that the model hasn't changed as expected, so time for another fix. We'll speed this one up too. And this same final edit using synchronous technology, we'll remember the section view that we used in our history-based approach. Well, check this out. Synchronous technology automatically creates sketches at that particular section, allowing us to use those to drive the model. And as it's that easy, well, let's add 2 sections. We can even hide our part so that we're left with an unobscured view for our required edits. We can then simply drag this profile to see how the design intent is being taken care of, which of course is modifying all of the solid geometry in the background, or use precision tools to make the edits. We use the same dimension tool we've been using all along to add 2mm, or round to 2, as we can now more clearly see the overall geometry. But what about that rear counterbore? Well, no problems here. Solid Edge has recognised the design intent of keeping these aligned, and of course you have the freedom to intervene if you wish. All changes done. Let's see how the times compare. 3 minutes 37 seconds for history based and 1 minute 49 seconds for synchronous technology. Both small numbers for this simple example, but that's half the time using synchronous technology. And it's not just about time, it's the removal of the guesswork, the tiresome interrogation and modification of the original design intent. Synchronous technology in Solid Edge recognises and maintains design intent on the fly, of course with freedom to change, allowing for sensible and predictable edits. Solid Edge, design better.